Maupay ngadlaw sa iyong tanan. Welcome to Engineering e-learning channel. So for today's topic, we'll be discussing about integration by substitution. Integration by substitution is another technique of integration by introducing a new variable in place of a factor or term involving the original variable of integration. There are two ways to integrate function using substitution. It's either by algebraic substitution or trigonometric substitution. For the first part of our sample problem discussion, we'll be discussing sample problem related to algebraic substitution. So first problem, example number 23, can be found in your workbook on page 97. Okay, example number 3, evaluate the integral of dy over 9 minus square root of y. So you will introduce a variable, a new variable. So we let 9 minus square root of y equal to x. So our new variable is x. So we need to determine and solve for y with respect to x. So our square root of y is equal to 9 minus x. So our y is equal to quantity 9 minus x squared. Okay. So for your quantity 9 minus x squared, if you're going to expand this function, this quantity, that would be equal to 81 minus 18x plus x squared. Okay. And here, you have your y. So we need to determine your first derivative of your y. Okay. So that's your dy. You need to use the expanded one. Okay. So getting the first derivative of 81 minus 18x plus x squared is equal to negative 18 plus 2x. So this is your quantity dx since you're solving your y with respect to x. Okay, so we can simplify this further. So we factor out 2. Should be negative 9 plus x. 2 times negative 18 2x. Okay, dx. So now, we're going back to our function, substituting the value of our dy and our y and 9 over y. So integral of dy all over 9 is square root of y. So we replace, what is our dy? That is 2 integral of 2 quantity negative 9 plus x dx. How about your 9 minus square root of y? That is equal to your new variable x. So you need to replace that one. So you have an x. So if you apply your property number 2, so you carry out your real number constant. So that is 2 integral of quantity negative 9 plus x dx all over x. Okay, we simplify further. If you simplify further, you have 2 integral, you distribute your denominator to your numerator. That would be negative 9 over x plus x over x quantity dx. Okay. So now you have your constant 2 integral. So that would be quantity 9 over x plus 1 dx. Okay. We can apply your property number 1 here. So if you apply property number 1, you distribute including your real number constant 2. So 2 integral of negative 9 over x and of course your dx. Then plus 2 integral of dx. Okay. So let's deal our first term. Because here, it's obvious that if we integrate, that would be the remaining is 2x plus c. So here you have 2. Applying also your property number 2. So you carry out 9. So that would be negative 9 integral of your dx over x. So we use our logarithmic formula number 3. Integral of du over u is equal to ln u plus c. If you do so, your final answer will be, that is negative 18 ln x plus 2x plus c. Okay. So, but you need to recall x. What is the value of your x? That is 9 minus square root of y. So, rewrite your final answer. So, your final answer, if you're going to rewrite your final answer, so that is negative 18 ln. So, what is your x? That is 9 minus square root of y quantity plus 2. What is your x? 9 square root of y plus c. So this is your final answer for your example number 23. Okay. So for your comments, you can send your comment to your Moodle account or you can send your message to our GC. For students who are not yet subscribed, subscribe to keep you posted and updated with our sample problem video weekly. Okay, let's proceed to our... Okay, for your next example, example number 24 can be found in your workbook on page 98. So evaluate the integral of e raised to 2z square root of 1 minus az dz. Okay, so we need to introduce a new variable with respect to existing function. Okay, so we choose the difficult one, the square root of 1 minus ac as our new variable. So we let square root of 1 minus a raised to z equal to x. And we need to solve for our x, for your z with respect to your x. Okay? So we remove the radical. That is a z 1 minus x. So for square root 2. Okay, so we need to determine z. So we loan both sides. If you loan both sides, we cancel out e. So the remaining is z is equal to loan quantity 1 minus x squared. And you need to get the first derivative of your z. So first derivative of your z. If you do so, that would be dz is equal to negative 2x dx all over 1 minus x squared. Of course, with respect to x dx. Okay, so we need to substitute our value of our z in our dz to our equation, and we need to replace our square root of 1 minus a raised to z with x. Okay, so if we rewrite the equation, if we rewrite the function, integral of a raised to 2z square root of 1 minus a raised to z dz. Okay, so integral of e to the z, we replace it with our loan 1 minus x squared. Okay, so for our radical, we replace it with our x, and your dz minus 2x dx all over 1 minus x squared. Okay, maybe we need to simplify this portion. If we're going to simplify this portion, that is a 2 loan quantity 1 minus x squared. So let's distribute the square. So this will become 1x squared. Okay, this is loan 2a. If you're going to evaluate this one, your a raised to loan will be cancelled out. So the remaining is your z. So this is your power, so you're going to transfer it here. So the remaining is your quantity this is from your equation, okay? So the remaining would be 1 minus x squared squared. So we bring it back to our function. That will be 1 minus x squared squared x quantity minus 2 x dx over 1 minus x squared. Okay, we cancel out one of this. So we cancel out one, cancel out this one. So the remaining is your integral of quantity 1 minus x squared x negative 2x dx. So, okay, we apply property number 2 here. Property number 2. So we carry out real number constant. So this is negative 2. Negative 2, we have x and x. That would be x squared. And your quantity 1 minus x squared. And of course your dx. Okay. Then what will happen next? Distribute x squared inside. So this negative 2. X squared. Quantity minus x to the 4th. Dx. You apply your property number 1 here. If you apply your property number 1, you distribute your negative 2 inside this quantity. So that is negative 2 integral of x squared dx and minus so since this is negative, so negative times negative, that would be positive. So positive 2 integral of x to the 4th dx. So you can apply your power formula here. So your power formula, if you apply your power formula, the remaining is negative 2 quantity x squared plus 1, 2 plus 1 plus 2 quantity x 4 plus 1, 4 plus 1 plus c, of course. So your answer is, that would be negative 2/3 x cubed plus 5 to 2/5 x to the 5 plus c. Okay, but before you proceed, you need to recall your value of your x. So you know your value of x, so just replace it with your x. Okay, so we recall. So that is equal to negative 2/3. What is your x? That is square root of 1 is your power cube. So it will become cube root plus 2/5 square root of 1 minus az to the 5th plus c. So it will become, your final answer is look like this. With negative 2/3, of course, cube root of your 1 minus a z plus 2/5, that would be 5th root of your 1 minus a z plus c. So this is your final answer for your example number 24. Okay, so let's move on to your example number 25. Can be found in your workbook on page 99. Okay, evaluate the integral of the square root of 1 minus cosine 3x dx. Okay. So for your solution, let's evaluate our trigonometric function first. So let's recall our value of our sine x over 2 in our previous sample problem. So sine x over 2 is equal to the square root of 1 minus cosine x all over 2. So if we still evaluate 3 halves x, This is equal to 1 minus cosine 3x all over 2. Okay. If we multiply this sine 3 over 2x with the square root of 2, what will happen? So 1 minus cosine 3x all over 2. So we multiply it with the square root of 2. So they will become square root of 2 sine 3 over 2x. But here, what will happen? So we'll let it go inside. So square root of 1 minus cosine 3x over 2. So we cancel out both square root. Diba? Square root of 2, same. The denominator, if we distribute the radical here, will be the same as square root of 2. So finally, your square root of 2 sine 3x over 2x is equal to square root of 1 minus cosine 3x. So we utilize this trigonometric relation. So we let the square root of 2 sine 3 over 2x equal to our radical 1 minus cosine 3x. So we replace this with our new variable. This is our new variable, square root of 2 sine 3 over 2x. Okay, so we rewrite our existing function and substitute our new variable, introduce our new variable. The integral of square root of 2 sine 3 over 2x and our dx. Okay, if we apply our property number 2, we carry out real number constant. Square root of 2, that is sine 3 over 2x dx. Now, we can determine our correction factor here. If we determine our correction factor, that would be u equal to your 3 over 2x. If you get the first derivative of your u, that would be 3 over 2. Finally, your dx is equal to the reciprocal of your first derivative of your u, du, that is equal to dx is equal to 1 over 3 over 2 du. So finally, that is 2/3 du. So we replace, so we substitute dx here. Okay. So square root of 2 integral of sine. So we replace 3 over 2x with our u. Then our dx 2/3 du. Okay. So we apply property number 2. We carry out the real number constant. The square root of 2 times 2/3 integral of sine u du. Okay, finally we're almost there. So this is 2 square root of 2 over 3. Then the integral of your sine u is negative cosine u plus c. Then you can recall the value of your u. Just replace with the original value of your u. Negative cosine, what is your u? That is 3 over 2 x plus c. So this is your final answer for your example number 25. Okay, for comment, you can comment down below, or you can send your message to our group chat, or you can send your personal message to your Moodle account. activities and exercises already posted in our streamline, so you can grab and download the exercises. So that's all for today. Thank you everyone and have a nice day.